Cool. So joining us here today, we have Noel Png. I'm not sure how you say his name, sorry.
No worries.
Joining us from Alba Orbital, which is a microsatellites company based in Scotland, I believe, given the name Alba. Alistair would like to interject. Go for it, Alistair.
No, sorry, pressed the wrong button.
Oh, okay, no worries. Yeah, no, so take it away. We're really excited to hear what you got to say.
All right, I'm going to share my screen. Hang on there. My laptop's
No
not really cooperating today. If it's not Scotch.
Yep,
that's true.
There's a few Scots on the call today, so you're in good company, Noel.
Yeah, are you able to see my PowerPoint slides?
We can, yeah.
Okay, so I mean, I was really debating, how technical should I get, because I do understand that, majority of the audience here today, I think most of us have a technical background, but I just really wanted to keep it really informal. So I'm going to call it Space Unicorns, and we'll find out why in a bit. And as you know, my name is Noel. Well, technically, I'm the business development type of guy, so sales and all of that. But I kind of do a bit of everything because we are a really, really small startup. We've got about somewhere between 20 and 15 of us. So essentially, we just end up doing a bit of technical, commercial, marketing work. Just a wee bit of everything there. So a bit about me. This is actually my first role right out from university itself. So if I do say something stupid or something wrong today, just feed me some rope there. I'm a bit nervous, but yeah. So essentially, my background's more towards satellite hardware development and defense research. So I'm not really going to jump into the specifics of that, but it's been a really, really technical journey there, and that really led me to Scotland itself, where I'm working for Alba itself there. So that's me, and that's a picture of my dog because he actually means the world to me there. So essentially, what we do at Alba is really we sort of function as a hardware startup. So we basically design the satellites. I'm going to stop sharing. I'm going to sort of show how small these satellites are, if you can sort of see my screen there. So essentially, it is the size of a human palm. Yeah, so the trends are such that satellites basically get really, 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 really small there. And we've literally found a way to pack many things within a small satellite. And we've basically managed to fit a camera inside there. And that's kind of like, and that has really formed the backbone of our solutions to, snapping the imagery of the Earth every 15 minutes with 24-meter resolution rates. But yeah, so really, really cool toys. And basically, what we've really done is that we've started, putting satellites en masse in space. So if you kind of look at it this way, we fit in about 3 or 4 of these little unicorns inside, and we sort of spring it out in space. And it basically helps us to do space things at a really, really low cost, because a lot of things that we do, we essentially just purchase the components from all your neighborhood electrical hardware shops there. We just get them, solder it together. So essentially, we are really driving the cost down low, and it is a pretty fun environment there. So that's kind of what I do. Back to my slide again. Hang on there. So yeah, so we build satellites. We've got our own testing facility. We even have our own ground station where we talk to the satellites. We manage all of this in-house. And today I'll be talking more about the optical aspect of it. So we're really going to be snapping images of the Earth at night there. And I'm going to talk about why we do that. So as I mentioned, small satellites, 5 by 5 centimeters, we've got our own satellite deployer. And if you look at my mouse there, this is where the game changer is. So basically, the long-term goal is to be able to, hoist somewhere between 80 to 96 satellites within a single launch itself. So the long-term goal is to really start building a huge constellation of satellites in space with a single launch itself there. And that's really where we're headed down in the years to come. And essentially, how we really started planning this product is basically we found out that existing data sets for night imagery, they are really insufficient. I mean, everyone does free stuff, and to be fair, a lot of these free imagery, they are pretty useful. However, the problem really lies in two things. The first is the resolution rates. I mean, most of these resolution rates here spans from between 5 kilometers to 200 meters. Our solution literally can go down to somewhere between 25 to 10 meter resolution rates. So that's the first thing. And the second thing is that the revisit rates. So a lot of these imageries, they're sort of being updated at a rate of every 2 weeks, every month itself. And that's something that at the moment, if you think of wildfire cases, humanitarian use cases, security, and all of that, people really need data that's being updated every hour, for example. And that's where we really come in with our 15-minute revisit rate itself. And well, this is sort of how the camera itself looks like. If you look at the middle component here, the device that I showed you over the video earlier, that's where we place our camera. You've got solar panels, and basically this is what has really gotten us the Silicon Valley funding. So essentially, even though we are a Scottish company, but we are registered in the US, in Germany, and in the UK itself. But this is where we got our Silicon Valley funding last year, giving us a bit of $3.5 million to really help us boost the constellation, do the R&D, and basically just drive our costs down low and really focus on data provision. So that's what we've been doing for the past 1.5 years. Things have been moving really, really fast. And so, yeah. And I think this is where I would probably think it's more interesting for a lot of the audiences here. So I think what we really see is that the market is really hungry. Not only do they want raw data, they want data that's sorted, arranged, presented, and even explained. So basically, we kind of have commercial customers who have no understanding of remote sensing at all, and they're going to come to us and say, tell me what this imagery does, tell me what does the data tell us, and tell me essentially what can we do with the data. And one of the most interesting things that I've really recently embarked on is, well, I'm obviously not from the UK, I'm from Singapore. It's a fairly small island, if you can look here, within Southeast Asia itself. And within the past 10 years, because of climate change, we've been having a lot of natural disasters. And basically, what I've started to do is to really work with various ASEAN governments and humanitarian agencies to utilize optical imagery from our satellites itself to basically predict natural disasters there. And this is one of the first studies that we've recently embarked on, is to really study how wildfires that happen in Asia, how do they spread, sort of be able to provide policymakers with a overview of how natural disasters happen, how long would it burn out, where would the fire be spreading to, and how do we sort of work from there. And basically that's the work and that's the direction that we as a satellite company, we are really headed into. And obviously a lot of times when we're doing remote sensing work, when we're doing a lot of data science, the analytical aspects, things don't work. And this is pretty much 90% of the time, this is pretty much my expression that I have in office. So yeah, I think that's it. Yeah, I think that's all that I really have for today. Yeah.
Okay. No worries. Short but sweet. No, thanks. That's really been, I already have a lot of questions, even from the short presentation. So, but I'll let other people jump in before I get going. Does anyone have any questions for Noel?
I have a question.
Yep, go for it.
How do you launch them into space?
Where do we launch it, or
how are these little satellites launched?
Okay, so it's essentially how it works is that we work with launch co-brokers. So at present, we've got 2 service providers, SpaceX from Florida and Rocket Lab in New Zealand. So we kind of do the launches every quarter itself there. So it's basically sort of like taking a bus, you kind of queue up, they place the satellites in a pod. So essentially this is what gets put inside the rocket there. And then it basically gets launched into low Earth orbit, somewhere between 400 to 500 kilometers. And, once the command is given, basically this thing fires out. It's like sort of like a spring, and, it just sort of ejects the satellites into space. And then this little boy kind of comes out. So basically it is foldable. So it comes out there, it starts to receive radio commands, and basically it starts pointing towards the sun, and you have a functioning satellite. So yeah.
Amazing.
Yeah.
Yeah, that's pretty neat. Alistair, I think you were maybe next in the queue.
Yeah, thanks. Thanks for the introduction. That was really cool, Noel. I've got two questions, if that's all right. So the first one is, how do you stabilize each satellite? Because I thought that's a sort of key component to know where you're pointing. So given they're so small, how do you stabilize them? And the other one was to do around the cost of launch. If it's so cheap to manufacture them, is the cost of launch a significant proportion of the overall cost? Like, is that the next thing that we need to get right down in order to make these tiny satellites more cost effective?
Well, I think this is a bit of a loaded question. So I'm going to address your first question more from a technical perspective there. So in terms of how it stabilizes, I do apologize if I can't go into specifics because we do have a bit of IP and all of that. But in a really generic mechanism, most satellites do have something called sun sensors. So it's not just think of it as a light sensor. So the moment it responds to light, it kind of gives a signal to the satellite to say that, oh, this is the direction that you should be pointing to. And we have something called reaction wheels. So they are basically wheels that sort of spin about its own axis there. And once basically it spins, it gives the satellite momentum. We point towards the sun, and that's where the solar panels sort of spread out and really get the most amount of power. So that's basically how we roughly stabilize the satellite itself. And then you do have additional add-ons like propulsion, that sort of, basically gives really small impulses of less than a Newton meter. But then the more you add on, obviously, the heavier your satellite gets. The heavier your satellite gets, it basically becomes a cost issue. To answer your second question about cost, so I think right now the launch market is fairly competitive, whereby satellite providers like us, we are literally not afraid of going to a different supplier if we feel that if the quotations are basically fairly expensive, because the market has really seen a boom, especially within the UK itself. There, we are looking at a lot of satellite launch providers across the UK and across Europe that are basically coming up with cheaper alternatives. So I think we're actually looking to really expand our launch offering. So in the event that if, let's say, so is the launch cost then, like if I had a satellite that was 1 ton and you had, I don't know, 20 of your satellites, is it all worked out on cost, or is it worked out on on weight, or is it worked out on weight and amount of size and everything else? Up to a certain level, it is your quotations are based on weight itself, but beyond a certain amount of tonnage that you're going to hoist up, obviously you can kind of start to negotiate for desirable rates there, which is why constellations are fairly attractive, because once you start doing a few hundred of them at a go, you kind of sit at a table and say, okay, if I'm going to be putting 200 of them in one launch itself, you can significantly drive the rates down there. So yeah.
Cool, thanks.
All right, I think Jesse had his hand up next.
Yeah, thank you very much for the presentation, Noel. I was kind of wondering, we're seeing several sort of satellite companies coming out with, these cube satellites, Planet Labs being a chief example here. I'm wondering how Alba Lab sort of wants to distinguish itself from some of these other satellite companies.
I'll probably answer it more from a engineering perspective. So most of these companies like Planet, they do really good work, and in fact, I think a lot of them they've been really helpful during the recent Ukrainian conflict. They've been making open data sources for policymakers and stuff. But most of them, they utilize synthetic aperture radar for their product offering. But we at Alba there, I think we've chosen to be a bit more old school. So we've literally chosen to go optical there, which is a fairly different product offering than what most EO companies are making there. And I think since we're so small for now, what we really sort of differentiate themselves in terms of the product offering is the level of service. Because like I mentioned, we are a vertically integrated company. So we design the satellites itself, we launch it, and we communicate with the satellites by ourselves there. So basically, we kind of really offer the seamless service for customers to really track how the satellites are being made, where the data is, and when would they receive it. So I do think that we are really going to make a difference in the level of service, which unfortunately, some of these bigger companies like Planet and ICI, they've grown to size such that they basically are operating call centers there. So let's say if I'm a customer in Europe or in Southeast Asia, you basically get redirected to a regional call center that deals with these sales-related queries there. And sometimes they may not really fully understand the technical challenge or the technical request that these customers make. But for now, since our team is fairly small and lean, I think that's something that is something that we're able to deliver on. But it is certainly a sort of a ongoing conversation that we always have every time we take a decision to grow. Because, yeah.
Yeah, and just quickly, just so I kind of understand your presentation, you were, I guess, showing night imagery, and you said that the satellites are solar synchronous. So I take you're launching all your satellites to be nighttime viewing satellites. Was that the implication there?
So for now, we are targeting the night market, but once we sort of build the constellation, we're basically we're going to be doing the day and night market at the same time. But okay. Just that from a commercial perspective, we've made a decision to focus on the night market because that's where the absence of data providers are. Yeah.
Thank you.
Yep.
Thanks, Noel. I think Julia had a question in the chat next. She's asked, who decides what you can launch into space? Is it only satellites?
Let me just... Okay, so like I mentioned, we are a US registered company, and we've got fairly good working relations with the US Space Force itself. So I think what we've done is to really sort of keep, defense agencies and all of them in the know-how. So every time we launch a satellite, we basically sort of give them the rough flight plan and we give them the list of coordinates and say that this is what we're going to do. Because the biggest challenge that small satellites pose to governments and defense agencies is that it is literally so small that they are really unable to track it. And I think at present, the industry is sort of having to redefine itself with a set of regulations that everyone kind of adhere to there. But until that is actually being done, we at Alba, we've literally just taken the initiative to just sort of like come forward and just say that, this is what we're going to do. We're going to inform the launch providers. We're going to inform US Space Force, so on and so forth, that, these are the manifests for our upcoming satellites, and all of that. So I think that is sort of a commercial answer. But as to honestly, who decides what we can launch into space, I think it is a fairly free market there. So literally, we are seeing the advent of more products being launched. So it's not only satellites. We're actually seeing things such as space tugs. So if you think of your pickup trucks that sort of pull a broken vehicle on the road there, we are literally seeing things like that being developed for low Earth orbits to basically pull satellites away to be repaired and manufactured. So I think it is a growing concern for many companies, as I think right now many countries are trying to sort of redefine how space is going to be regulated there. So I think that's something that the conversation has to really take place at a much higher level. Yeah.
Interesting. Yeah, really interesting. Mehul, you had a question next, I think.
Yeah. Thanks, Noel, for the presentation. It was lovely. My question was around how would a saturated market look? Because there's only limited space, pun intended. So then how does one deal with failures and debris? How do companies deal with that? Let's say satellite fails and there's a lot of debris, which I guess, I think they bump into each other and then they create more debris, right? Yeah. So how is that tackled?
So obviously, one of the you are correct to really point out that satellite debris is a huge issue there. So basically, right now at low Earth orbit, so anything up to 500 kilometers there, we are seeing sort of a traffic jam kind of issue where basically you have a lot of things flying around. But I think what we've really done is we've really we do have our systems in place, well, from a software perspective that basically allows for autonomous intelligent behavior. So just think of the way bees sort of fly around to forage for food there. And basically what we've done is that, we are literally looking into nature-inspired methods, putting into a mathematical sort of equation there and sort of applying it to satellite behavior and sort of see and to sort of really ensure that, our satellites are able to sort of avoid certain things at certain periods of time there, and also be able to converge over a certain location if multiple satellites are needed at a specific time to take the imagery there. So that's the first part. And The second one comes more from a commercial perspective, because we are really operating constellations itself there. In the unlikely event that we do have a space-related collision, for example, it doesn't really cause much of a hole in our plan, because if you have 200 of them, losing one or two of them doesn't really punch a hole in terms of the ability to provide coverage. And to sort of answer your last question about space debris again, because our satellites are fairly small, once the end of the mission lifetime, around 2 to 3 years, they essentially just burn up as they deorbit. So basically, it guarantees literally no debris in the atmosphere itself there. So I think, in a sense, it is a cleaner solution as compared to cube satellites itself, if you think about it that way.
Lovely, thank you.
No worries.
Scott, I think you had your hand up next.
Yeah, I did, but Noel just answered it at the end of that. Yeah, my question was about lifespan for these satellites, which 2 to 3 years. Is that correct?
Yeah.
Okay. Yeah. No, that was my question. Thanks a lot for the presentation, Noel.
No worries. Yep.
Okay.
I think to sort of add on, recently there has been additional ESA regulation that says, when you're launching satellites, you do have to like file a flight plan to sort of tell them what's the deorbiting lifetime, and all the kind of things. So basically, even when we launch our satellites, most companies these days, they have to sort of give a really, really definite plan that says, this is my mission lifetime, this is when the estimated deorbit date is going to be, and this is how it's going to be deorbited. So these days, everything is really, really clearly documented and regulated. Yeah.
So just to touch on that, actually, how are these microsatellites deorbited?
So essentially, once the end of the mission lifetime itself there, it sort of loses the propulsion ability. So gradually, so basically, it just sort of gradually just orbits around at a decreasing altitude until it reaches the atmosphere and it just basically burns up.
Okay.
Yeah.
Okay, so the orbit just degrades. Okay.
Yep.
Cool. Thanks.
All right, I think Will, you had your hand up next.
Yeah, I was going to ask a question about like the obviously small sounds. So what does downlink look like? And do you need to do you have to downlink frequently because you've got storage capability issues? But it's a small device, so what is there a limitation around the size of the aerial? And do you need to have a ton of ground stations as a result? How does that look?
So to be honest, at the moment, the biggest issue that we face is in terms of getting the imagery down into our ground stations. So you are right to sort of say that downlink itself is a huge concern there. For now, we do have one ground station in Germany itself, and we're going to be adding 2 more well, I can't really talk about it, but it is going to be a Scandinavian country there. So basically right now we are in a process of gradually scaling operations up so that once we sort of get more satellites, we're able to sort of, basically downlink more imagery. So I think it is a sort of a delicate balancing act that we have to do on a technical perspective, and a commercial decision is to sort of make sure that either one of them doesn't really lag behind. Yeah.
Interesting. Thank you.
Yep. No worries. Yep.
I have some questions.
Yep.
First one, you're talking about like the data pipeline. You've had that slide with the Lego bricks being just a mess and then coming all the way into the house at the end. How do you guys handle that at the moment? Like, how do you do the processing? Do you have a platform for orders and catalog that a user can, request new imagery or access your back catalog? Just interested in specifics around those things.
So typically, I think most companies, they sort of have sort of a pay as you go, sort of like a credit. So you purchase a certain amount of credits, which enables you to sort of view X amount of imagery, for example, there. So that's one of the business models that we've considered. And I say that because we've only recently transitioned to the EO market, and that's only like a year ago with our Silicon Valley funding. So for now, we are just basically dealing directly with customers. So basically, it's literally one of us on the other end getting in touch with the customer and saying that, here's the imagery. But I do think that as we sort of scale the business model up and as we start to get more customers, we are going to be looking at sort of a front-end sort of customer website portal type of arrangement where customers are able to sort of log in and view the imagery. But that's really down the road, because as I've mentioned, we are still fairly early stage in the remote sensing market. So I'm not going to sit here and say that we have figured everything out. We're actually really trying to find out what we are good at and really find out how we should operate.
Yeah, definitely.
Yeah.
And then the processing side of things. So you have your raw imagery downlinked. What are the next steps for that imagery before it gets to the customer?
So for now, this is purely due to headcount reasons. We're only limiting imagery to sort of, we're only limiting our service offering to basically customers just getting a optical imagery in GeoTIFF format, and they just sort of obtain it. Anything else, the add-ons in terms of analytics for now, it is purely academic from our end there. So it's not really a commercial offering. But what we've opted to start doing is to get in touch with governments, ASEAN, military, for example, because I'm formerly from the military back in Singapore there, and sort of start that early discussion to see how we may want to do our data provision services based on what the market needs. So we are sort of trying to figure things out on the go. Yeah.
Cool. Yeah, it sounds like you guys are very nimble, which is great.
Yeah.
Any more questions from people?
Yeah, I guess we need to kind of expand on that question. Like, what's your timeline or roadmap for getting to that, stage where you have those, derivative imagery products on your site? Or are you just planning on just raw imagery for the time being?
I think that is a question that's best answered by the founder of Alba itself, which unfortunately he isn't here today because he's actually down in Netherlands for a ESA conference there. So I'm unfortunately not really able to answer that from a commercial perspective. Yeah, sorry about that.
Fair enough.
No problem. Any more questions from people? I've still got a few, but I don't want to hog the microphone. So
no worries.
Okay, I'll fire off another one. You went through the Y Combinator startup funding process.
Yep.
How is that? I've seen a lot of companies go through it, but I've never really heard specifics about how it actually works.
I would probably describe it as being the most harrowing experience. So the prelude to the Y Combinator itself was, I think, where the entire team itself, we had to go into this business operating model where we had to approach numerous companies regionally and basically globally to sort of get them to sign letter of intent to say that they may want to purchase X amount of imagery there. And I think that really took the team about 3 to 4 months of just pure direct business development work, which I think saw us having about $86 to $90 million in LOIs being signed. So that kind of formed the foundation for us to go for Y Combinator. And at YCom itself, obviously because of COVID, it was done remotely. And from there, our founder, Tom Walkinshaw, he basically had a bunch of, appointments lined up with various investors. And that kind of just started the conversation as to how much people wanted to invest in us. So we do have a bunch of investors, but the notable ones, are mainly James Park from Fitbit, Flexport. So most of our investors, they actually come from a really diverse background there. So they don't come solely from a technical or data science kind of startup. Some of them do healthcare and like all of that. So yeah.
How does it help with investors being a Scottish company? Because there can't be many Scottish companies who put satellites into orbit. Do you find that you have like some sort of angel investors who are just interested in promoting Scottish businesses in this space?
I would think most of the investors, they do get rather intrigued because when you talk about UK space companies, the perception that most of them have is that we are based down in England there. But due to the level of government support and the recent level of, just basically government support and from the Scottish government and from ESA itself, that I think Scotland is actually really, really upping the ante in terms of becoming like a space city in that sense. So within Glasgow itself, we do have numerous space startups, notable ones are like Spire and Clyde Space. So basically, that kind of gives us the economies of scale, access to talent and, space-related activities within Glasgow itself there. So I think that itself has really helped Alba Orbital to raise its profile on a global stage so that, every time we go to different events, to investors and stuff like that, the moment we mention that we're from Scotland, Glasgow itself, the reputation of Scotland being as a space, space city or space place itself just really helps us, and it is a game changer. So yeah.
Okay, I'm behind the times then. I need to read up on my. I'm from Scotland myself, so I should be aware of this stuff. But I've been out of the country for too long. That's great. Jesse, you had a question?
Yeah. So I appreciate this might not entirely apply to Alba, but I'm curious about as you kind of push into very low Earth orbit with these microsatellites, what sort of additional challenges you might face as you try and maybe operate at lower orbits?
So I think it is a bit of a double-edged sword. So generally, the lower the altitude that the satellites orbit at, the easier it is for us to talk to the ground stations, because just think of it as like a Wi-Fi signal. So the lower we are to Earth, the easier it is for us to talk to ground stations. We can get more data rates down. We can get more imagery down. However, from a control perspective, that's a bit of a challenge, because around 300 kilometers in space, things are fairly cluttered. And that would mean that a lot of times when our satellites are going over a certain location of interest, there may be something that's blocking our way there, which is why we have to sort of push it up to a 400 or 500 kilometers in altitude itself. But then by doing that, it presents additional data challenges, because it means that the amount of imagery we can transmit down gets affected. So it is a very delicate act that we have to really balance and sort of figure out as we really scale up our constellations. So at present, we've got 19 satellites up. 4 of them are dedicated for Earth observation. The other 15, they're doing a range of other missions, IoT, providing internet coverage for the South American counterparts and all of that. So yeah.
So then the challenges at that lower altitudes aren't so much about like orbital mechanics, more just about like communication logistics.
Purely more from a communicative perspective. In terms of orbital mechanics, I would say that we are fairly confident that our control systems can able to do the job there, because it is relatively small. So to really orient ourselves to a specific area and all of that, it's actually not much of a challenge compared to having a cube satellite or even a huge sort of ESA related satellite, which takes a fair bit of time to turn around there. Yeah. So just think of it as a small ship and a big ship. But yeah.
Okay. Thanks.
No worries.
Do you mind expanding on some of the other satellite use cases? You mentioned like IoT and things like that. Yeah, we don't just do imagery, so we're really keen on anything related to like Earth and space, basically.
So essentially, when we started the unicorns itself, there we realized that because we were able to have so much cost savings. We started approaching high schools and universities that really want to do STEM outreach, space outreach there. So essentially, a lot of the IoT missions actually came from university enthusiast clubs. So it was pretty cool, because we started seeing first year students with their professors literally building this little baby in like the lab itself there, and because the components were so cheap, you can just order it from online, put it together, test it, and launch it there. So that's where a lot of these student groups have sort of graduated from university, and most of them have actually founded their startups in Brazil itself, Argentina, Brazil, and they've basically moved on to devote a lot of their skills and talents towards helping the community. So one of the big cases are basically providing wireless internet coverage for farmers in Brazil itself, because unfortunately some parts of the city and the infrastructure isn't that good, and they basically came up with the concept of using low-cost space solutions to provide internet coverage for people living in rural areas there. So essentially what we have done is to basically just make space so cheap and accessible that instead of going to a bigger company and doing it, because the cube satellite costs about 250 grand, we basically managed to push it down to a significantly smaller value. Yeah. So IoT is one of them. We do get a fair bit of science experiment missions. So we do we do get scientific agencies across Europe that really want to do studies that study the composition of the atmosphere itself and all of that. So it is fairly dynamic. Once in a while we do get fairly crazy requests from people who want to redesign the satellite, put in a different payload. But I guess it's just part of what we come. It just counts with the job. So never doubt it in Alba itself. Yeah.
That's fascinating. You must have such a range of competencies to deal with all these different payloads, basically.
Yeah, and I think I can't really emphasize enough, because I was an international student myself. When I came to Glasgow, the amount of emphasis they have placed on space education and space outreach is so good, because they literally have got like, events where they get space companies to come to universities to talk to us about space. So to be honest, originally when I first did my master's in engineering, I was just thinking of going down the finance route, getting my master's, going through one of those grad programs in Goldman or JP Morgan, crunching numbers and all of that. But it was one of those STEM space outreach where, they literally just brought out a similar CubeSat model, and they were just telling us about space. And I think that's how I just kind of ended up in this. Yeah.
Yeah, cool. I mean, space is sexy. There's no denying it. Certainly more than working in a bank.
Yeah.
Cool. I think that's all the questions I've had. Does anyone else have any more questions? I'm not hearing anything. So, Noel, it's been a pleasure having you. You've answered so many questions now. I think we've had about half an hour of questions, which has been great. Yeah. So I'm going to stop recording.